Today we're going to be looking at the connections between the measures of an interior angle, the measures of an exterior angle, and the number of sides within regular polygons. Just to review, we have a couple formulas out there that we need to make sure we are aware of, make note of. If you haven't written them down, jot them down somewhere because we will come back to them as we work through this. The first is for the sum of the interior angles of any polygon. That is given by the formula n minus 2 times 180, where n is the number of sides. The second fact we need to know is that the sum of the exterior angles of any polygon is always 360 degrees. And then lastly, we're going to be working a lot with regular polygons today. A regular polygon has both all sides that are equal and all angles that are equal. We say the sides are equilateral and the angles are equiangular. Okay, we're going to talk about interior angles and exterior angles. An interior angle is just one of the angles on the inside of the shape here. This is an octagon, so it has 8 interior angles. And the other piece we're going to be talking about is exterior angles, and that is this piece on the outside. It is formed by taking one of the sides and extending it, and then that gives you the exterior angle. This octagon also has 8 exterior angles. They're not all drawn. Okay, so there's some terminology that we will be using as well. Okay, so we're going to start out with a couple review problems, and then we're going to expand. The first one says, find the sum of the interior angles of a regular hexagon. A hexagon has 6 sides, so I'm going to use my n minus 2 times 180 formula. And I'm going to plug in 6 for n. So I'm going to take 6 minus 2 times 180. And then that's 4 times 180. Now I want to show you something you might not be aware. The technology department pushed a link out, or a bookmark out to your iPads before we left for break. It's this white Pearson TestNav graphing calculator. I am going to attempt to open this here in split screen mode. Give me a minute. And you can use this as a calculator when you're working on your stuff here. So it's going to load the MCA practice test app so you can see the graphing calculator, but it's just the calculator. Okay, so I'm going to look at this, and I want to do 4 times 180. So this is a really nice way to get access to a calculator if you don't have one. And then I'm going to scroll down. It's not working well in split screen, so I'm just going to multiply it out again. So I'm going to figure out that this is 720 degrees. Okay, that is all 6 angles here added together. All 6 added together is 720 degrees. Okay, same thing for number 2 here. I'm going to find the sum of the interior angles, so I'm going to use that n minus 2 formula. But instead of 6, I'm going to put in a 15. And 15 minus 2 is going to be 13. And I'll go over here. So this shape has 2,340 degrees that make up all 15 angles. Okay, so if I were to count up all, measure those angles and add them up, they would add up to 2,340 degrees. The second type of question you may be asked would be to find each interior angle. Because this shape is regular, I know all the angles are the same. So I'm going to go back up here and say there were 720 degrees total. All 6 interior angles are the same. So that's going to mean each angle has to be 120 degrees. So looking at my diagram, each one of these angles here is going to be 120 degrees. Okay, and it doesn't ask me, but I could answer this question. If I wanted to find the exterior angle, I know the exterior angle makes a straight angle pair with that interior angle, so I could just do 180 minus 120 to get 60 for that exterior angle. So I can find some of those relationships and use them to solve. Number 4 asks for each interior angle of the regular 15 gon. I'm just going to take the 2340 that I had and divide it by 15 because there's 15 angles there. Each angle would be 156 degrees. Again, I can do that because it's a regular 15-gon, so all the sides and all the angles have to be the same. So that 2,340 degrees gets divided evenly. Okay. This one's maybe a little bit more of a challenge. It says the sum of the interior angles of a polygon is 2,160 degrees. How many sides does a polygon have? Okay, I don't know how many sides it has, that's what I'm looking for, but I know my formula for the number of degrees is given by this. And I know that the number of degrees has to equal 2,160. So I'm just going to go ahead and solve this equation. I'm going to choose to get rid of these parentheses, so I'm going to distribute that 180. And then I'm just going to solve. I'm going to add 360 to both sides. And then I'm going to divide by 180. Which gives me an answer of 14 sides. So I can work that formula backwards as well. Oops. Okay, another question you might see is something like this. What is the measure of each exterior angle? Well, if you remember at the very beginning, we said the exterior angles always add up to 360 degrees. If the shape is regular, I'm just going to take 360 divided by 16. Each exterior angle would be 22.5 degrees. Okay, well then each interior angle, if I were to draw a 16-gon, it wouldn't go very well. But if you can envision, my shape looks something like this. Obviously it doesn't have 16 sides, but the interior angle's right here. If the exterior angle that was paired with it was 22.5 degrees, to find the interior angle, I'm just going to take 180 minus that because I know that they have to be supplementary because they make a straight angle pair together. So that's one way. I just did 180 minus the exterior angle. The other option is to figure out how many degrees there are total. So I could do the n minus 2 times 180 formula, plugging in 16. And I could say, okay, all of them together add up to 2,520 degrees. But I want to know what one angle is. I could divide that by 16, and I'm going to get 157 degrees. 157.5, excuse me, degrees. That's the same answer that I got before. Actually, I'm going to get this calculator out of here just to have a little bit more room to work. It's the same answer that I got before. I don't care which method you use, but the point is sometimes you can just use other facts that you know about interior and exterior angles, and it can make your life a little bit easier as you work through some of these. I just have a couple, or just this last one for you. This one says the measure of an interior angle of a regular polygon is 144 degrees. I want to know how many sides the polygon has. So if I'm going to work backwards through this, again, I don't know how many sides this shape has, but I just draw this because it's a nice picture to see what's going on. If my interior angle is here, I can very quickly find my exterior angle, and I'm just going to do 180 minus 144 to find that, and that exterior angle is 36 degrees. Now I know that all my exterior angles add up to 360 degrees, and I know that it's regular, so I know that they're all the same. So I'm just going to divide by 36 and see how many times that goes in there, and I know there has to be 10 sides. Okay, that's the fast way to do it. There is another option to solve this. It's a little more complex, but I will show it to you just so you can see it. So the other way to find this is to say, well, I know the total number of degrees is given by n minus 2 times 180. And if they're all the same, I can divide that by however many angles there are. that gives me what one angle equals. We did this up here. We did this top part was our n minus 2 times 180, and then we divided it by how many sides or angles there were. Well, here I don't know how many sides or angles there are, so I'm just going to leave it as an n. Well, now this is an equation that I have to solve. So the first thing I'm going to do is probably multiply both sides by n to get rid of this fraction. And then these cancel here. So I'm left with n minus 2 times 180 equals 144n. And then I'm going to distribute that 180 through. And then I'm going to move this 180n over to this side. And then I'm going to solve for n by dividing by negative 36. Now, I don't know about you, but I hope you're looking at this thinking like I am, gosh, I would much rather just do that. You do not have to use this method. You certainly can, but the point of this problem is sometimes it's easier to figure out the exterior angle and then use that to solve. Okay, so our objective today was to work on this angle web, to work on these connections and figure out how I travel back and forth. Okay, between an interior and an exterior angle, I know they have to add up to 180 degrees. They're supplementary. So that's going to help me work quickly back and forth. An exterior angle to the number of sides. I know that exterior angles always equal 360. So that gives me a quick way to work there. If I divide by 360 divided by the exterior angle, or 360 divided by the number of sides. And then here, to work this way, I'm going to use that n minus 2 times 180 formula, and then maybe divide by the number of angles. There's a bunch of practice problems for you. I want you to try some of these, but hopefully this was enough information to allow you to get off to a good start to that. Again, keep these, this formula and this number in mind as you begin your work on these problems. Good luck.